Hey guys, this is Miss Phoebus. This is lesson 10 on ancient Mesopotamian mathematics. And we talked last time about the Sumerians and the Babylonians and how they kind of together, but I think the Babylonians really pulled a lot of stuff from the Sumerian and even the Akkadian civilizations. We didn't really talk about the Akkadians. We did talk about, or you heard me talk about, and some other people talk about the development of a base 60 number system, and not necessarily a positional number system, but we did talk about a place value system where they arranged their numbers um, in that base 60 notation. So um, the Babylonians, that was one of their biggest contributions, was the place value of their systems. Um, So we're going to look at just kind of some other things that the Babylonians and the Mesopotamians, because they kind of bleed together, what they have contributed to our uh, society even today. I mean, they were around for quite a few years, a long time, and how do they still impact our lives today? So the Sumerians and the Babylonians needed to describe quite large numbers as they attempted to chart the course of the night sky, and they developed a sophisticated lunar calendar. So the Babylonian calendar is one of the greatest achievements of antiquity. It combines a solar and a lunar calendar in such a way that the beginning of the year never wanders off far from the spring equinox. And so these are pieces of the one of the Babylonian calendars that is still around today. So the Babylonians excelled in astronomy, and they had many of the constellations we see right now they were categorized by the Babylonians. They kept careful records. They recorded celestial events because they felt that that would shape the future. These were signs from either the gods or just it was going to have a determination in future events. Under Hammurabi, the lawgiver, because he wrote Hammurabi's code, in 1800 BC, star catalogs and planetary records were compiled. And so they're, of course, they're not just writing these things on paper, they are etching them in stone, which is why we can still find them. We can't see a lot of the ancient Egyptian stuff because not everything was written in stone. On papyrus, you get to lose quite a bit. So this is a star planisphere found in the library of the Assyrian king Ashurbanipal, who reigned from 668 to 627 BC in Nineveh. The function of this unique 13-centimeter diameter clay tablet, in which the principal constellations are positioned in 8 sectors, is disputed, but the text and drawings appear to be in an astronomical nature. You do see that there is quite a bit of wear off of this, so some scholars believe that it might not necessarily be astronomical. Babylonian astrologers kept careful records about celestial happenings, including the motions of Mercury, Venus, the Sun, and the Moon, on tablets from 1700 to 1681 BC. Later records identified a solar eclipse in 1063 BC that turned day into night. And the famous eclipse of 763 BC was recorded by Assyrian observers in Nineveh. And so we have an almanac mentioning the position of planets. We have records, solar eclipses. So they are really watching the skies, and that's all science, guys. Babylonian astronomers are credited with having discovered the 223-month period for lunar eclipses. This is a tablet with a list of eclipses between 518 and 465 BC, which also mentions the death of King Xerxes, who is a Persian ruler. Another thing that influences our lives, you are either in geometry or you're going to be in geometry, and we know that we are dividing up time into 60 seconds in a minute and 60 minutes in an hour, and we're also dividing circles into 360 degrees, so we can divide up our clocks with a base 60 number system. And then there is a Babylonian clay tablet where there is a circle with a square built inside it. And this diagonal represents the square root of 2. So these have been annotated. You can see the markings, the numbers that are written there. There's 30. Um, so the diagonal displays an approximation of the square root of 2 in 4 sexagesimal figures, 1, 24, 51, and 10. And so what they do is they create these decimals by looking at 1 plus 24 over 60, that's the 24, plus 51 over 60 squared, that's the 51, plus 10 over 60 cubed, and add all those pieces together to create a very, very close approximation of the square root of 2. The tablet also gives an example where one side of the square is 30, resulting in a diagonal which should be 30 square root of 2, or 42.4263888. So these are just a few, with the addition of the invention or innovation of writing, the wheel, the plow, the arch, all those things, irrigation that the Sumerians and Babylonians did. So all of those things, as well as calendars and paying attention to lunar eclipses and solar eclipses, and and even their base 60 number system, all of those things are still uh, influencing our paths, the things that we do, the things that we look at as human beings. And I think that is pretty cool. All right, that's it for this video. You have another video to watch about trigonometry. Trigonometry is the study of trigonometric angles, sine, cosine, tangent, and it pulls in a little bit of that right triangle Pythagorean theorem stuff. So you have a video to watch on the Plimpton 322 about the world's first trigonometric table. I'll see you in the next video. Bye.